Hello.
Welcome back.
Haha.
Another week, another stream, as they say.
Glad to see everyone's here. I see
Yeah.
Kevin, Justin,
Staple of
Dominic.
the chat. Dominic,
Hi.
maybe Jack will drop by.
Possibly, if he's woken up at this point.
Yep. But as people filter in, we've got a very exciting stream today.
Yes, we do.
Long-time guest,
Yeah, I've had this guy on a couple times before now, hey?
friend of the show,
Yeah.
Professor Eric Wooldridge from SCC down in Kentucky. Yeah, I guess we'll do a brief overview and then we reintroduce him as more people come in. But
Yeah.
we've been working with him for quite a while now. Some of you may remember him from our January streams, but he's been using Quinly, testing Quinly for other printers.
Yeah.
Yeah, he's been one of the first people
He's
to
done a lot
use
of
it.
cool stuff with Quinly.
A lot of printing, a lot of testing, and Eric himself, and we'll let him introduce himself in a second here, he's a professor at SEC and he runs their additive manufacturing center. So he is like the guy to talk to about 3D printing. In fact, his YouTube channel is called The Additive Guru.
Yeah. It's a pretty accurate name, to be
Yeah.
honest.
Yeah,
He knows a lot about 3D printing.
absolutely.
There he is.
Yeah, we can hear him laughing in the
Just a
background.
very slight laugh.
Yeah, but I guess before we get into that, we should introduce ourselves for anyone new. I'm Mateo. I'm one of the co-founders of 3DQ, and I work on mostly our technical stuff. And then I'm joined by Stephen McKillick.
Yeah, I'm the Quinly product lead at 3DQ. And I've been here for about a year and a half.
Yeah, which in 3DQ terms is a very long time.
Yeah, most of the company's lifespan.
Yeah. Cool. Yeah, let's bring him on. Here is our good friend Eric.
Hello.
They can see you. Say hi to the audience, Eric.
Hello, audience. It is always a pleasure to be here and to talk about what's going on. As I mentioned, my name is Eric Wooldridge, and I'm a professor for the Additive Manufacturing Program. I'm the director of the AMC, the Additive Manufacturing Center, and that's actually for the state of Kentucky. We are the directors of all of Kentucky's Community Technical College Additive Manufacturing 3D printing program. So we're located at Somerset, but we're actually part of a 16 college chain. So we do 3D printing statewide and create all the curriculum, get to play with all the cool stuff, and troubleshoot quite often.
Troubleshooting, so fun.
Troubleshooting is a part of the cutting edge. That's just the reality of it, and it's exciting stuff. And playing with the new technology and seeing how it specifically applies to what we do here in Kentucky. Probably the easiest way to understand why we do what we do is our standing mandate. And our standing mandate for Kentucky is to get additive manufacturing skills into the workforce as quickly as possible. And the primary reason that is because Kentucky is a major aerospace producer. We produce a lot of aerospace products, equipment that goes on planes, DoD applications, and additive is where everything's going. So our overall goal is to have a workforce statewide that is very comfortable with additive. So that's what we do. Right now, normally I do the presentations from my other office. Today, we're actually back in the lab. Still have to have a mask available. And we are getting ready to start courses on Monday back to face-to-face. So we're getting everything geared up to restart.
Yeah,
That's
school's
awesome.
starting back up, eh? That's good
Yep.
stuff.
Yep.
We're looking forward to it.
Yeah. And for students to see the new stuff we've got, they haven't seen some of the new
That's
equipment
right.
that we've been falling with over the past few months. So it's going to be pretty exciting to get everybody back in here and kind of blow their mind with what's happened since they've been gone for about 4 months.
Yeah, no one's seen the lab in a while, I'm guessing.
Yeah. Well, you guys have a pretty big lab, actually. So I think you should probably tell the audience, like, you have a lot of 3D printers. Why don't you just give them a bit of an idea of
Yeah, a description
the
of the lab.
scope of your lab that you've got?
And I'll throw up some photos.
So now I have to talk about it from the state level because my lab has now, expanded. So at this particular site, we have we have about three primary additive manufacturing labs on this particular campus, plus this actual recording room where we're adding in our VR system next to complement the whole thing. That of course includes a CAD lab and also two polymer labs, and then our industrial side lab where we do the higher end production with metals, HP systems. So that's what we have here. But the bigger picture is what we have set up across the state. So now we actually have 10 sites across the state, including ours, that are additive ready. About 6 of those have roughly around 12 to 22 3D printers at each site. It's part of an initiative we refer to as RAMI, the Rapid Response Additive Manufacturing Initiative, which was responsive from COVID, so that we could actually fire up printers with a single person at each site and produce hundreds of thousands of parts. So now our network has gone from like a couple of sites to, we have probably somewhere between 100 and 200 printers statewide of different types and technologies doing some really cool stuff. They'll be doing education, and then in the event of a disaster or opportunity, we will send a file out and say, activate, and the entire system activates and starts producing the same thing. So it's we have a statewide cloud manufacturing system as now part of our lab. So it's pretty exciting stuff.
Yeah, that's pretty brilliant. I think
Yeah.
it will, as everyone's seen over this past year, like having, centralized sources for products or for manufacturing can be a very delicate situation, especially if your line to that factory gets cut off. But spreading manufacturing over now 10 sites in a single state will make it much more robust to any sort of emergency situation. And I love that idea of using 3D printing for it. And I guess a good question would be, why do you see 3D printing being used for this over other types of manufacturing?
That's an excellent question.
Thank you.
And the fact is, we saw exactly why. When COVID hit, you have one supplier that breaks the chain, and the chain's broken. It could be the transportation. It could be a union, sort of like a walkout from a union site. It could be one particular material supplier. We saw that in some of the tsunami issues of Japan, and that we actually had cars that couldn't go offline because of a particular paint that wasn't available.
Mm-hmm.
So the supply chain itself is actually very, very weak, especially when you consider that we build these gigantic supply chains just to produce oftentimes one product. And it's a complex thing to get one product overseas to certain locations. But with additive, there's no retooling. There's a piece of equipment, a micro factory, if you will, that can ship from product A to product B and back. And then it can be allow essentially one person, in some cases, no one, you can do it remotely, to initiate a production run. And then all you have to do is have delivery. So just breaking down that large, complex chain into much smaller sites all over the place just makes sense. The DoD especially sees this, as when I say DoD, I mean Department of Defense for the U.S., sees the supply chain weakness as one of the greatest threats to the security of our nation. And, in really many cases to the world, because we have to have things to operate. And if we were relying on this complex chain that can easily be broken, that's not a very good state of readiness. So what we're seeing is the DoD sees additive as not only to make a type of product we could never make before, but to make it on demand and in remote locations wherever you are. And that same mindset translates into potentially everything, even everything from our spare parts to our automotive components. We can actually do this anywhere, and additive is the only technology. Injection molding, you can't do this. Injection molding, you have to have huge equipment, massive molds, a lot of labor and unsustainable intensive work that goes into the creation of those molds, and those molds make one thing. You know, when you look at CNC, again, huge equipment, very expensive, slow, and it has to take a big chunk of material and carve out a part. And then all that waste goes into our environment itself. So again, not a sustainable approach. With additive, you build up from one molecule at a time, and you have a product. You don't have a mold. You don't have to retool. You just transition from one to the next. So just several reasons why additive is a supply chain fix in the great scheme of things.
And I think the analogy of like just the word supply chain, like a chain, as everyone knows, is only as strong as its weakest link. And supply chains are literally what is it like just you try to thin them out as much as possible, and if any link in your chain breaks, as you described, your entire supply chain is now broken. You can't get the products that you need
Yeah.
where they need to go.
Fewer links means fewer chances for failure somewhere along the line.
Yeah.
And it honestly can be as simple as one ship. One ship just gets stuck in the Suez Canal,
Yeah.
and what happens then?
Yeah.
Right? So you thinning that chain out, making it down to that one link we don't even really consider until it happens, and we're like, what's going on? We can't get our stuff anymore. So it's just wise to be looking at technology to do this a better way that doesn't rely on this constantly evolving and changing and shifting politically, especially supply chain.
There even, I mean, we saw even with the insane cold snap in Texas, it caused a plastic shortage that messed up filament supply for months afterwards, and we had like a really hard time getting certain materials because of a weather phenomenon. We're going to see more and more of that, and that's not something that you can even control politically, or the only way you can work around that, and it's going to get worse and worse in the future, is by distributing your supply chain, or shortening them, producing closer to the consumer, and spreading around the source of the product. So yeah, I think we both have very, very similar visions for how 3D printing, where it can benefit the world in terms of manufacturing, and what the best way to deploy it is.
Yeah. Well, it turns out like Quinly's kind of designed around that sort of idea where you can have multiple Quinlys in different locations, and you don't actually need a human in some cases to operate them. You can just send them files remotely and have them print out. And we're seeing this now kind of becoming more and more of a real thing. And actually, you've been doing a few tests as well recently, just proving out the whole concept of automated 3D printing.
Absolutely. And automation is what we're after too. Additive has already had leaps and bounds of advancements, especially over conventional, but now we want to go further because automation is this next step of that evolution where the 3D printer is self-operated. We now are reducing, well, let's just look at our labor shortages. We have labor shortages and material shortages because of labor all over the world. And we had companies shut down essentially because they couldn't have so many people in place. Well, if I have a printer that can be remotely controlled and that can be told to print one product than another and not need human interface for that process, I mean, that solves all sorts of problems. The labor, the COVID restrictions, everything. And so automation is what every form of manufacturing right now is looking at. And obviously additive is right there in the mix, and this is where it's going.
I think something that you alluded to right at the beginning with the mandate for your program is to bring up skilled labor in this industry, and just through industry research, actually one of the biggest roadblocks for the scaling of 3D printing is its over-reliance on labor, and the fact that a program like yours even exists is just a demonstration of that, where like you're getting this mandate to get more and more people familiar with additive, and it is because additive is so intensely um, reliant on labor that it's not possible to scale it well, and that's where we're seeing now, as you said, Quinly is coming in so that when you do bring a new person in the industry with the correct skills, and they will be able to operate many more machines than they would have, because the machines, the manual tasks, the things that don't actually really require skilled labor at all, are now automated, and they can focus on their expertise, which is things like converting parts for additive, or optimizing files for additive, or coordinating, production deployment efforts, instead of scraping parts and applying glue sticks to print surfaces.
Yeah.
Right? Like that's not what you're training anyone to do, right?
We hope
Hopefully.
not. We have to
Yeah.
train a little bit sometimes, but the overall goal is that. And we actually have a statement that we use all the time in the lab. You even hear me say it a lot of times on our Additive Guru channel.
Mm-hmm.
Additive or 3D printing is not about the 3D printer. It's about the mentality. We see the case in point of your all's product. You have advanced additive to that next level, where it's less and less reliant on a person to interface with that piece of equipment. So they get to focus on, how do I redesign this product to be even better for additive? How do I continuously make this product lighter, faster, stronger? How can I focus on the mentality of this process and the logistics to produce more and more product, while not having to go scrape off a build plate or get a part off, and keep constantly going back to that process, where how can I stay on my computer and in my mindset for improving this whole thing, versus the manual and, crazy enough to say it, the tedious task of clearing a printer.
Yeah.
Right? So
Absolutely.
the more mentality time, the more thought process time we can put toward this technology. And even the sales, the sales component is another thing about it too, for the small business guys that we have. We want them selling. We want them focused on getting their market further and further and farther. We don't want them to keep focusing on having to clear the printer. We want them to be out there making more orders.
Mm-hmm.
So that again is another completely sort of like unsung hero of this automation movement. The less you're doing with the printer, the more money you're potentially making by selling and improving your product.
Yeah, and it's definitely a multiplying effect on that. I think one of the most interesting things that we see among our own customer base is there's, like, in general in the industry, there's a bit of a misconception that if automation can make your printer print twice as much or 3 times as much, then that replaces the need for 3 printers. But what we actually see is the exact opposite, where automation is reducing your time with that one printer so much so that you can actually consider running more and more machines. And a lot of our customers are now coming back and purchasing more Enders and Prussias and putting Quinly on those as well. And you can see it's almost counterintuitive in that each printer itself is printing far more than it used to, but now they actually have this opportunity to scale and focus on their business, or focus on their part design and scale that up. And so they end up buying more machines, and then they end up at a spot where now they're printing at like 900% capacity than they used to have when they were running a manual machine.
Yeah. Well, when your margins drop by like a factor of like 5 or 10 or something, it starts making sense to invest more into this actually productive system, versus just increasing the amount of work that you need to do. You're just increasing your capacity without really adding much extra effort.
And I think
you're all absolutely right. And one of the things that I think people don't realize, and this is true for so many things, is that you just need to get the ball rolling. Your first client and customer that bought the first kit discovered something. And then they realized, because of this freedom, now I need to scale up even more with the same. And that's a lot of times what we have to tell our students. You need to try it. You need to get get started. You don't want to wait around just thinking about it and, not exploring. You need to try something and get started and see what happens, especially when new technology comes along, and especially affordable technology. You need to get out there and try it early so that you can go ahead and make the next decision based off that data. So I love the fact that your customers are already having that switch and responding to it because they got started early. They made a smart move and got into it quickly, and now are benefiting from it, and now have such a fast acceleration of their own operations.
Yeah. And maybe just because I noticed we have a lot of new people that have joined us. We're speaking with Professor Eric Wooldridge from the Additive Manufacturing Center of Excellence down in Kentucky. He operates now 10 sites all over the state. How many printers do you have across all the sites?
I would say somewhere between 100 and 200. I don't
100
really
and
know.
200.
We had several different grants supplying product for each site. So I've kind of lost track of how many. Here at this site, we have about 60 to 70 that we operate just here. So all those other sites, we're putting out somewhere between 20 and 30 printers per those other sites. So we might even be over 200.
Yeah.
I'd have to have one of the other folks check that, but it's a lot.
That's a lot. Yeah, that's a lot of printers.
Yeah.
Definitely one of the largest operations out there, and it's a excellent proof of concept for decentralized manufacturing. So yeah, I guess I should also prompt anyone in chat. I see like some of the comments that were coming up while we were talking are pretty cool. So Justin 3D was mentioning how because of the trucking industry shortage, that caused Taco Bell items to come off the menu. Like it had, I know it has like such weird repercussions where you wouldn't expect because so much is relying on a single system. And I think Kevin was saying how
yeah, I just saw a mention of just there's a lack of qualified people to run the farms.
yes.
And it turns out that the people that know how to calibrate and maintain printers are also really good at a bunch of other things that are a lot more important, like slicing, part design, and optimization.
Yeah, and you don't want them to be dealing with the printers as Eric said, for sure. But you will always you want to extend, like through automation, you want to extend their influence and spread their ability over as much manufacturing capacity as you can.
Yeah.
And that's actually what we're going to start seeing over time as well, is that as we get better and better at automation, and all of these, again, I'll refer to them as micro factories, we will start to really evaluate, well, who's got downtime? When can I really balance the system out so that product is happening all the time and nothing's down? But we've got automation, why not take advantage of the downtime that the machine is sitting there between 2 and 6 in the morning not doing anything? We now have that option because no one has to go in and do anything. We just divert the load to that. So you're going to see with this whole cloud concept, which, to be fair, is one of the reasons, one of the supporting reasons that we did the RAMI project. The Rapid Response Additive Manufacturing Initiative was to demonstrate that it could be done and to get the ball rolling of this cloud manufacturing concept. So there's a lot of reasons we pushed into this field, was just to raise the awareness that this can be done.
And I think that's a good transition into the testing that you've done with the automated system, because that kind of goes hand in hand with deploying. On screen, I've pulled up a photo of all the iris boxes you printed, if you want to talk about that.
Yeah. I've got a little box of goodies too.
Oh, you've got them there too. Sweet.
Yeah, I brought them in here doing the donuts. The iris box is a product that we already produce and have been producing for several years in the lab, because it really makes additive shine out. And I mean that by saying, here you have a product that has moving parts. Right here. Sounds like Pac-Man.
Oh my God, yeah.
But it's one of the bigger versions that we have. But it has moving parts, and it was never assembled. This is a product that comes right off a printer. You take a little razor blade, you cut some tabs, and you have a product of moving parts that's a container, non-assembled, completely additive. So it shows, first of all, how advanced additive is over conventional, because we can't do that with injection molding, we can't do that with CNC, so it's the only way to make it. So we produce a lot of them so that we're actually giving them out a lot of times during tours to industry folks to help explain why additive is different. And we produce, anywhere between 600 to 800 of these every year just for promotional material. A lot of times we fill them up full of Skittles and M&Ms, prior to COVID, of course.
Right.
But we
Right.
pre-stock them with candy, and that made them sell, go even faster.
Of course.
But the fact was, the previous form of production was staff had to actually maintain that production. You had to go print, clear the printer, restart, clear the printer, and we had plenty of downtime because the overnight prints, didn't take up the whole time. So when we got a chance to put the Quinly system to play here and actually evaluate it, we wanted to see several things. First of all, how much downtime can we eliminate? And here in this lab, we're very cost-minded folks. So we consider labor time to be the same as any employer should. Is that if I'm paying someone to operate that printer and clear that printer, how much money am I losing every single minute that happens? And so the overall goal was to evaluate where's the cost benefits to full automation. So we set up basically a test. If it's okay for me to go ahead and explain it.
Yeah, absolutely.
Yep.
Go ahead.
So the overall goal was we just put a comparison between what we had been doing with an ender for years now and compared to a Quinly system. We did basically a run of 74 iris boxes, about this size, a little bit bigger, roughly the size of your hand. And we wanted to see what the comparisons were. And it was a fairly simple test in concept. We set it up. I think it takes about 2 rolls of filament to produce all 74. And we compared the actual time it took the lab technician to clear a bed, restart, the time it took the lab technician to actually drive to the lab in the off hours, because we don't work 24, but our printers could. So we had to account for that, and just each individual time to do that. And essentially, it adds up. By our best case scenario production with I shouldn't say conventional, we'll say a manual way of printing with just the ender, we estimated that the technician would be doing about 44 trips from his house back to our lab because of off-hour operations to facilitate that 24-hour production. I think it ended up being around 244 minutes of time, and of course we factor in the cost of the actual staff to do that, and we didn't include benefits, so that should have been thrown in as well.
Mm-hmm.
And we compared it to what happens when we just fire up the Quinly and let her roll and slide a box underneath it. We had this nice little slide that took a shout out to Tyler for rigging up the Tyler slide, which allowed it to slide right in and change the filament twice.
Yeah.
So grand scheme, for the Quinly system, 10 minutes of technician time. 10 minutes for the entire batch run versus the 244 minutes of the way we were doing it. And that's data that is just like mind blowing. And any executive at any company is going to look at that and say, well, this is a good decision. Why would we even question it? 10 minutes versus 244. If I don't have to pay someone 234 minutes per hour to do something, well, that's going to make sense. We actually, our actual overall report kind of broke it down a little bit further with the upgrade and everything to go with it. We figured that the cost benefit payoff was around a month and a half, just to do this. And so there's no way in the world that any manufacturer, any small business, or even large business is going to look at a payoff like that in terms of equipment investments and reliability and say this is a bad idea. So
Yeah. Well, sometimes it takes a couple years to pay off, right? Like sometimes these investments take a while, like more than a year or 2 years. Like in larger projects, like 5 years to pay off. 1 month is pretty crazy.
Yeah, I mean, like I said, it boils down to like a decision made with, it's not even a decision. For anyone that's actually in business and actually thinking through a cost analysis, this is like almost, a ludicrous consideration to not, especially when you consider not only just our labor situation, but just the fact that we can't always trust our labor. We don't know we're going to have an employee next week.
Yeah.
Or if the employee's going to be there to keep that production. That was 44 trips from that technician's house to our lab after hours. In reality, we all know that there's no way I have an employee that's going to be able to make 44 of those things consecutively. I think for the 17 days it would take to do this.
Right.
There's going to be something. Somebody gets sick or had to be doing this, and because this was off hours, this was weekend hours. So like, there's no way that doesn't change, and so that immediately makes it even more beneficial to get that way. So yeah, just from a very, very simple example, we saw that this is a no-brainer for production. And so right now it's knocking off iris boxes. Tyler's slide is just dropping them right in. It's not only just doing that, but it's doing our other product we'll talk about too in a little bit. But it was surprisingly obvious to us when we started just pulling the data. We kind of knew it was going to be that way just because we had been playing with the system a little bit, but the data was really impressive by the time we actually processed it out and said, wow, that's pretty good.
Mm-hmm. Yeah, I think it's, here. We've got the results pulled up, and I can talk a bit about what some of our other customers have seen, where like you had a very, very like your case was like you said, very reliable labor, and something we found with our other customers who aren't running print labs yet, but are using printers as a means to an end for business purposes, is their time is much more expensive than somebody you hire to run the print lab. And so what we found, like basically using the guidelines of your study and looking at and talking to some of our customers, is they're seeing a pretty similar thing where in your case, I think it's a 96% reduction in labor. With our customer base, we're seeing that or even greater, because a lot of them do not have time to give constant attention to the printer, and then they're either not running their machine always, or they're giving up other things in order to have their machine run more, and then that, not only is there a direct labor cost associated with that, but as we spoke about earlier, there's also an opportunity cost where if you're spending, like 4 hours resetting machines over a production run, you could be putting those 4 hours to something way better and much more productive to your business. And I think also there was a something in your report where you had mentioned 17 hours, and was that like additional auxiliary labor in terms of travel time itself, or
Yeah, I think I'm trying to think back to a few of those numbers for it here. I think what we factored in was the drive time to get there. So it's about 18 minutes from his home to the lab. I live about 40 minutes away, and if it had been my rate, it would have been, much higher,
right?
As you say. And so, yeah, you're talking about 17 hours associated with, the drive time back and forth each time. With 44 trips overall, it's just really going to add up pretty fast.
Right.
It was, and again, those were controlled situations. And you're absolutely right, too. The fact that someone is not doing what is really making the deal, which is the marketing and selling the product, that's labor costs plus, in all honesty, missed opportunity. They're not making a sale if they're working with the printer. They're not putting out a new video that pushes social media to go to their product if they're working with a printer. And that value alone can just not be underestimated for its potential, or overestimate, I guess you could say it that way.
Yeah.
You can underestimate the impact of not doing your marketing. Case in point, so there's a couple of folks that I know that use Additive as their their production. They actually built their business just around they could 3D print things. And it's a couple of marketing guys, and they weren't manufacturing folks, they were marketing. So he's like, we spend all of our time marketing. And the more marketing, the more profit, the more actual sales to happen to need these printers. So yeah, there's so many factors here that play into this and just make it an economical decision.
Yeah, well, it helps having like the cost of Quinly itself as an operator. We found it's about 2 to 4 cents per hour. So if you can hire someone for 2 to 4 cents per hour to do your scraping and part removal, like, I have to say that's a pretty good deal. I don't think most people will work for that much.
Some hobbyists might.
We actually included that with our numbers. I think we had ours is about it was actually 3 cents. It was actually operator cost per part was about 3 cents per part. So we were breaking it down to the operator cost per part. The manual method was almost like $3, I think. And so it was virtually nil for the Quinly application. Of course, your material cost is the same, your electrical cost is essentially the same. That operator cost, that's quite a big difference between 3 cents and $3.
Yeah, and if they touch it for like five minutes on the printer, that's what, like $3-4, like depends how much you're paying them, but
depending if they're in Canada or in Kentucky.
But that just like multiplies your part cost probably by like 10 times, even if that might be an underestimate,
right?
So.
And I think one of the big things is people always go to material cost, which is true, it's fixed in both systems, but I think because 3D printing now has this opportunity to scale to a massive degree, like 96 to 99% reduction in labor means that a single operator can now run 20 to 100 times more printers than they used to. And so that presents a massive opportunity for scaling, and with scaling comes the economies of scale when it comes to printers, printer parts, and especially, I think, printer material. You can get even now, you can get some very, very good pricing on filament when you buy in bulk. And I think as these operations grow more and more, and as more filament is just being produced and consumed, I think the overall cost of material is going to go way down, because you'll start benefiting from the economies of scale when it comes to the filament itself. So I think long term, if people switch to an automated system, they'll also start seeing an industry-wide benefit of less expensive materials, because I think everyone wants 3D printing to start taking or growing a piece of the manufacturing pie. And in order to remain competitive with the rest of manufacturing, you've got obviously the automation, which is brilliant in terms of reducing cost. And then over the medium to long term, you're going to start seeing other things come down in price as well in order to match the higher volumes that the industry is pushing. And that I'm really excited for. And we even we speak to filament manufacturers about that, and they want to be producing more filament, so they'll give you better and better price breaks with the more that you're ordering, and with the more that everyone together is ordering.
Yeah, well, some interesting stuff is we're seeing now that 3D printing with an automated system is becoming more and more competitive with injection molding. Like before, 3D printing, you could have your 100 part was your break-even volume, where if you go higher than that, you just get an aluminum mold and injection mold. But now with automation, that number's going up to 1,000, 10,000, 50,000.
Actually, Stephen just did a study or a report for the HVAC industry about a specific nylon part. Do you want to maybe talk about what you found with that stuff?
Yeah, so I found, this tiny little nylon part takes about 10 minutes to print, and on our automated systems, it turns out that these little, they're basically just gears, but they're kind of weirdly shaped. they take about 10 minutes to print. They cost about 6 cents per part to print on an automated system. And it turns out to injection mold those parts, you'd have to do about 300,000 in order to break even with that 6 cents per part cost.
And then, and I know you can speak to this with the cost of tooling. But as you said, like way up at the front of the stream, once you make an investment in tooling, that is set in stone, or I guess set in steel.
It's a sunk cost, as
Yeah,
they
it's
say.
a sunk cost. Whereas with the 3D printers, if you suddenly have to modify that part, you're good to go. You just change your digital file, and you're no longer dealing with like physical molds that you have to make.
Yeah, well, your 3D printer is a mold for every part that exists
Yeah, yeah,
in
right,
the world.
right.
That's
So
a
it's,
good way to say it right there. I like that.
Yeah,
Yeah. I may steal that one. That was a good one to say. Your 3D
oh, please do.
yeah, definitely.
It's a
Credit, make
shape-shifting-
sure to credit Stephen for that.
There, what's also interesting, so we did a report on that. Now, we did this before we had automation. We had the Quinly system. And so there's a sustainability factor that goes into this as well, because every time you make a mold, a steel mold, and you extract that raw element and ore from the ground, and you transport it, and you tool it, and then you use it, your environmental impact versus printing is astronomically different. And as you say, you are stuck with that design. So not only is it worse for the environment for us to make a mold, there is a cost opportunity loss there, or a potential profit loss, because the amount of time it takes us to make the mold, and then the inability to change the mold to a new product, is a loss of product profit on the market. So you're losing money in multiple venues. You're losing it back to the economic, or I should say sustainable offset. Then you're losing it in the fact that you can't respond to the market fast enough. So if I have to retool that mold where the printers have done it the next day, that means I can't introduce my new product to the market as fast. I might be another 4 or 5 months before I can get my mold retooled and retrained. So there is loss of market impact. There is loss of environmental impact. There's just loss in what do you do at the end of the life of the mold when you no longer make the product. There's that further loss that you have to deal with. So there's a lot of hidden losses and costs that people just don't think about when they're considering this equation, but are truly real losses.
Mm-hmm. It's all waste. Like there's just so much.
Mhm.
Yeah, it's inefficient, and we've built these monolithic systems to support such an inefficient form of manufacturing. I think economies of scale is actually a representation of manufacturing being inefficient, because it only starts to make financial or economical sense to run such complex systems if you're making 100,000 or 1,000,000 of something.
Right.
And when you can split the cost of such a complex system across, like, you're literally taking your cost and saying, in order for me to sell this product, I have to split it across 1,000,000 products.
Yeah.
And it just shows like how bulky the systems we have today really are. And I think that's why, I mean, everyone watching, and I think everyone here agrees, like with 3D printing, you don't have that massive overhead investment that you have to make. It's so inexpensive, and with a system like this, it pays itself back on like an order of magnitude faster than some of the larger systems out there.
Yeah, well, having also the ability to not have your parts locked up in like inventory. If you have a bin full of 100,000 plastic bits, those are all just sitting there, and you have to do something with them eventually. And maybe you don't sell as many things as you thought you would, and now you have all these parts just sitting around, and what are you going to do with them?
Mm-hmm.
Probably throw them out, recycle them, something. That's all wasted value at the end of the day.
Justin 3D asks what happens with all the Happy Meal toys.
Oh.
Like,
Oh man. don't want to think about that.
Yeah, like,
Just somewhere in the world, there's just a pile of like Scooby-Doos or
oh,
something.
yeah, definitely.
Oh, that is totally true. Actually, we were working with a small business that uses additive, what we consider low cost additive, like desktop models. Perfect for the Quinly system and Prusa's. He actually went to injection. He actually considered injection molding. So he actually went and got some estimates of cost. And yeah, it was going to be the typical somewhere between the $5,000 to $8,000 for the mold. But then they were going to want, I think, $2.50 per part on top of that.
Right.
Wow.
So he's like, it doesn't even cost me that much to print it right now.
Yeah.
So I'm going to lose money all the way through. He said that was what shocked him is that, they want the small cost, but then they're going to charge that much to actually produce it for him. He
Right.
said there's just no logic to this. And it's to what you said too. It's like we are supporting a system that has always been the way it has been. And look at the inefficiency if we have to do so much just to make it even make sense.
Yeah.
We have to spend $1 million of marketing and staff and work just to get up to where we can actually produce enough of the product so that it makes a profit.
Right.
That doesn't even make sense.
Yeah. Well, it's nice having 3D printing. The cost per part is like a straight line.
Yeah.
If you want to print one thing, $1.
Right.
10 things, $1 per
It's
part.
still $1.
1,000 things, it's still $1 per part. Like it
Yeah.
really doesn't change because it's just a constant
And now,
amount of material and labor per part doesn't
yeah.
get scaled up or down.
And you bring that threshold, that barrier to entry all the way down.
Yeah, it goes from an $8,000 mold to a $1 print.
Right, because even if that part eventually, maybe you're selling like, 200,000 a year, maybe it does eventually make sense to injection mold. You now have an alternative option as you grow your business to that volume, that doesn't have that massive barrier of entry. You're not going to have to lose money on every single part you sell until you hit, 200,000 or whatever, because you've now got a fixed cost per part and a very, very, very low overhead and a system that can scale as you do and also maintain that fixed cost per part. In fact, you do experience to some degree as you start buying material in bulk, even today, in the short term, you do experience a little bit of economies of scale because you can get filament much less expensive if you're buying 100 rolls at a time. I think in our experience, if we buy 300 kilos at a time, it costs us about half as much than if we buy 10 kilos every couple of weeks. So that even there you start seeing benefit, and then you now have this option will carry you to when a giant system makes sense. And then there, like you had mentioned, Eric, these externalities like, well, if I'm going to move to injection molding, am I going to do it myself? Do I need a facility, or am I going to contract it out? And therefore, do I need a supply chain and a warehouse and inventory? Whereas that doesn't really change with printers. You always need a location for the printers, and you can add printers wherever you need, but it scales very, very, very smoothly. There's no like big lead time. If you want to make twice as many parts as you were last week, you just double the amount of printers you're using, and your operation does not change in a significant way.
It doesn't. It doesn't at all. You know what? And even think about this too. Let's just think about lead time. Let's just say that we're on the East Coast and we start up our company and we're making all this product. Well, we want to actually start selling on the West Coast faster. Well, I'll just set up a printer lab over on the West Coast and not have to ship as far. We can put these printers, if you go back to our cloud manufacturing approach, we can put these printers anywhere. And so we can actually move our manufacturing from, one incredibly small and efficient space to another incredibly small and efficient space to 3 or 4 or 5. So
Right.
we can set up our own manufacturing and, essentially vendor locations all over the nation or the world because of this easy to establish footprint. Also, it kind of tickles me a little bit. So when you understand understand the automotive industry, most automotive manufacturers are not truly manufacturers. They are designers and assemblers. They subcontract everyone else to make all their stuff. We see that across the board on all of them. They're always putting out bids for, widget A or B that goes in your car. We'll just say the cup holder. The cup holder is going to be bid on by someone else who does plastic injection molding. They do it huge amounts. They get these molds, they do the contract, but here's the catch. After they fulfill their requirements for that product line, they are responsible for so many years to provide additional supplies when the need arises. So maybe that car is not produced anymore, but that cup holder is still needed, for replacement parts. But that company now starts losing money because they have to take their system down, bring the old molds back out of storage, get them ready, put them back on, and then overproduce in hopes that they're going to have enough to meet that current demand.
Oh, you really need to check out my, there's a thing I'm writing right now that goes over exactly this issue, like the spare parts inventory problem. And especially now there's like right to repair bills coming out all over the world, and manufacturers that had to support a product for maybe 1 or 2 years, now they have to go up to all the way to 10 years supplying spare parts. And you don't want to be having just random little bits of plastic in your inventory for 10 years at a time when you're maybe sending out 1 or 2 per day. And you have a bin of like 100,000 or something.
Yeah, your minimum order for some of them is like tens or hundreds of thousands.
Yeah. And then at the end of that 10-year lifespan, when you're finally free of that, burden, then you've probably got a whole bunch of those parts left over, and they're not worth anything to you anymore, so they just go into the landfill.
Yeah.
Just like that. It was funny that when some of the companies who've approached us wanting to learn, and the first question is, they say for this aftermarket product that we don't do as our main line anymore, could we print that? And that question comes up all the time. A lot of times the answer is yes.
Yeah.
So then that's where they're ironically getting into additive, is to facilitate when this injection molding, this product scale is no longer viable. And so it really alludes to the fact that if we're going to end up being there eventually, why don't we start with additive? Why don't we build the infrastructure of additive that can do line A, line B, and then switch back to line A whenever we need it later on? It just makes sense.
Yeah, I think it'll actually start from the back end of a product's life cycle and then move slowly forward. Because when people realize, like, oh yeah, this is pretty nice, we can produce spare parts on demand, then it turns out, well, actually, we could also just start there and produce all the parts for the whole product on demand.
And I think just to reiterate, I think the companies that are ultimately going to win with additive manufacturing are the ones that recognize that if they want to support these products long term with replacement parts, that they do design those parts to be printable and replaceable with 3D printing up front. Because honestly, like we're almost a perfect example of that, except we're not doing years of replacement part storage yet, because Quinly's only been out for 6 months. But in the case that a customer arrives with a damaged shipment and has a part that's broken, our parts in Quinly are already 3D printed. So either we can just print an extra one off and send it to them, or the dream is, which we can do with our customer base, is send them this G-code file and have them print it themselves on site and literally get replacement in a matter of hours, and they could be across the world, right? I think like that is, things will trend towards that. I don't think that we'll have 3D printers in everyone's house as was like hyped up back in 2012, but I think we'll have something very close to your model, Eric, where we have cells, manufacturing cells spread out everywhere throughout the country, throughout the world, and the primary form of transport for products is going to be over the internet and not via massive shipping and logistics supply chains. It's just going to be, you're going to send an email to this facility, they're going to print off whatever parts are needed there locally and do like a last leg kind of local shipment to their customer. And I think it's also we're going to see, as that starts to happen, it's actually really beneficial for local communities because it's now bringing manufacturing jobs very close to where the products are being consumed, and you're going to see less and less of this centralization where you might have certain regions of the world specializing in doing or manufacturing very specific things. I think it's going to start spreading around, and going back to your program and your mandate, there is going to have to be an availability of labor that can run printers spread everywhere throughout the world. Even if it's minimal per region, it's going to have to be available in every region.
Yeah, I really like the way that you said that. Like, it's actually so much easier to send a bunch of ones and zeros across the ocean than to send a box full of parts.
Yeah.
Like, it just makes sense at the end of the day. And also, I think, like, going back to, like, the skilled labor, it'll be nice to see eventually parts designed for injection molding that can also be 3D printed.
Yes.
Because a lot of people now with 3D printing design skills, at least myself, I know that I could make a part that could both be injection molded and 3D printed. Like at this point, you can see some really complicated injection molded parts that have, thin walls and sprues and stuff. But the idea is you could actually design a part so that it works as an injection mold with some draft and stuff, but also as just a normal STL file that can be easily 3D printed, and they're both kind of interchangeable.
Mm-hmm.
And you can see that just having some huge impacts where, yeah, you can injection mold your huge first million parts or something, and then use your 3D print file to supplement the rest of them.
Or service locations that don't buy as much product. Like you can expand your market very easily by maybe, I don't know, maybe you're a US based company and you're interested in selling into, I don't know, like Montenegro or something, very small country, and you want to test the market out there. You can deploy your 3D printable parts there and see how it fares, and use that as your manufacturing base until the volume grows and until you can justify having a larger manufacturing outfit out there or setting up a supply chain for tens or hundreds of thousands of parts.
Mm-hmm.
And of course, how you get to that point is you're going to have time to market. You're going to have time to actually keep the main thing the main thing. And the manufacturing, honestly, should not be the main thing of some of these new and innovative products. To go back a little bit on the thought of like, making it both additive and injection molding compliant, you're going to see that happen very, very quickly in the automotive industry. A lot of the automotive entities themselves are in the process of training their engineers to understand additive design because of this horizon of what additive is. So if the engineers are being trained to design that way, you're guaranteed to see that the contracts that come out for parts to be made for these automotive industries are going to reflect that. I do like the fact that the new 2022 Ford Maverick is going to have this new T-slot for adapters. We make the a parallel for the Picatinny rail that's on rifles. Whatever accessory you want to make fits to this particular profile, which obviously is going to be a boon for 3D printing because we can 3D print that profile and attach anything to it.
Right.
So that is a good sign from my perspective. A universal slot to a receiver slot in automotive is a great thing for us to start seeing.
That's awesome. Yeah, and hopefully, I guess they can't really license it, so because it's already in existence. But that's awesome. I hope to see more and more of that. There are actually a couple questions in chat that people are asking as we were discussing this. One of them was about filament out, and so on the Quinly there is filament out for the Prusa Quinly, and we're working on supporting it for like all other printers as well. And that is a pretty critical component because once you've automated everything else, your main thing is going to be running out of material. And So I think what we're already seeing among our users is that people are trending towards larger and larger spools to avoid that downtime. And yeah, filament out is going to be is a big component of that. The other question was for bulk manufacturing, is the storage of parts expensive? And I think you can probably speak to this, Eric, but I think a rule of thumb is it adds about 25% to the cost of your part storage and inventory.
It, of course, it depends on the size of the part for sure, but when you factor in the square footage, the taxes on the building, the taxes on the property, the security that usually comes with that, all of the insurance based on every bit of that square footage, you'd be amazed at how much increase that occurs with that. You know, there's a reason why products are about, you know, somewhere between about 4 to 5 times their actual manufacturing cost when we actually buy them, if not higher. So there's just so many hidden costs with every bit of space that you have. So I actually, you know, 25% is definitely a strong number, and in some cases higher.
Yeah, that's good to have someone back that up, but it is surprisingly expensive. I think a lot of people don't realize that a quarter of your cost is just the part sitting somewhere.
Yeah.
I guess as we're talking about future things, have you seen the Quinly for Ultimaker yet, Eric?
I haven't. We've been talking about it a few
Ooh.
times in our side conversations, but I haven't seen it yet.
Okay, let me see if I can share it to you. I'll send you a link to.
We just recently announced this. It was a couple days ago.
Yeah.
But we've been working on this kind of in the background for months now.
I'm gonna show it on the stream, and I'm gonna send you a link in our chat. So here it is.
I really like this shot when it starts off.
Yeah,
Very cool.
it's very mysterious. Okay, I'll send you checking the Google chat. Yeah, we started working on it in February, and so we're pretty excited to be able to show it for the first time.
Yeah, it's a little bit more complicated than the other Quinly systems that we've got for Fuchsia and Ender. Took a little bit more figuring out than just using the nozzle as part releaser.
Yeah, it's pretty exciting because we spent a lot of time designing something that would fit within the envelope. Oh, I see, it's playing audio.
Oh, is it the
Sorry
audio
about
from
that.
the
Yeah,
video?
I muted it.
Ah.
Apologies, Dana.
That's cool. Yeah, that's really cool.
Yeah.
I guess this is just the intro screen, and they're not getting the full
They're not getting the full experience.
the
you're
full
saying.
video. Yeah.
Okay, let me put it
Any
up.
chance we could get the YouTube player on?
Yeah, of course.
Some live editing. Mateo's really good at this.
The tail end of the stream always devolves into me trying to show cool stuff live.
We've just got too much stuff to show.
Okay, here it is. Let's switch over to this.
Yeah, just a couple more notes in the Ultimaker. It was pretty fun figuring out how to fit everything inside too. It's a pretty compact machine and likes to keep everything nice and tidy.
They don't give you a lot of space to work with.
Not really, no.
It took us like a month to even figure out how we were gonna get all the features in the space of the Ultimaker, because we've got about an inch in the front and 2 inches on the side and like half a centimeter under the print bed that we can use.
And we had to figure out like a whole door opening and closing mechanism that fits within a 1 inch like width gap,
Hmm.
and then the whole part clearing mechanism has to first of all cover the entire bed and also stow within that really uh, 2-inch wide space on the left there. And it also has to look good because Ultimakers are like they value aesthetics so much, so people that don't want their Ultimaker to look ugly.
Yeah, it's it was a bit of a challenge, but we're super excited to be able to show it off.
Yeah.
I think like because you were mentioning at the beginning too, it's these more Ultimaker is a demonstration of a more industrial system, and I think we want to support those as well as the as things like the desktop machines, because the
Yeah.
desktop machines will take you so far, and they work brilliantly if you have the expertise to run them. But sometimes if you just want like a workhorse machine, you're looking less at Enders and more at Prussias, and then especially if you want like a full-blown production system that's capable of handling any material with ease, you're looking at something like an Ultimaker.
Yeah, well, like the skill barrier for an Ultimaker is quite low. Like when we first tried this out, I just did this as if I was a pretty new person. I just knew how to open Cura and click slice, and it was a pretty plug and play experience. So I think companies that have Ultimakers, they don't want to be spending a lot of time fiddling around with, settings and tweaking little mechanical bits. They want their printer to be a tool rather than, you know, like a hobby tool blend
Yeah.
tinkering machine.
And I mean, speaking of more like upper end printers, we're working with you guys on Quinly for Sidewinder. I think we can talk a little bit about that. It's a
Yeah, I wasn't going to say anything until you gave me the green light on that one.
yeah, it's
Yeah,
a new announcement. No, we haven't announced it before, but yeah, absolutely. We can talk about that.
Yeah, we'll keep some of the other projects for the future under
Talk.
wraps. But
Yeah.
that one we're really excited about because the Sidewinder is one that we pushed out quite a bit into our RAMI network, the overall statewide system. One of the reasons we use the Sidewinder, it's pretty simple. It's we can get a lot. It's a workhorse that we can easily work on. It's got a really good heat bed system, and the volume is really nice. So during COVID, especially the actual COVID time, we were producing, thousands of face shields using Sidewinders. Of course, manually clearing them as they went, but it was a very powerful system, so we replicated it throughout, which also gives us the ability to utilize it well with our system because we issue a G code out for the entire state system for the Sidewinder. And so all the Sidewinders all start up and take off and go. So the idea of adding the Quinly to it was pretty exciting. And we've actually printed off some of the very first bracing parts and put them on there. Jesse, shout out to Jesse because he actually went through and took the photos and did the measurements and did the checks to see how they're going to fit. I think there's a little tweaking there,
Hmm.
but just right off the bat, it's going to be a good fit.
Cool.
And with that, again, with that build plate, conversion system and just the reliability of the system, we're going to have a really nice productivity. Definitely compared to like Enders, the Sidewinder's maintenance needs are much, much lower.
Yeah.
We've even gone through the process of adding on, self-leveling pretty easily too. So it's also a great start.
I think actually you had mentioned really quickly, but this is something that's been a bit of a conversation in our Discord for the last couple days. And Kevin in chat was asking about it too. When you had mentioned like you create a G code and you deploy it to all of your hubs around the state, like how do you find that? Does the same G code work everywhere you've set it up? Have you had to make special arrangements at the different sites to make sure to like to ensure a consistent environment? How have you found that model?
That's a really good question. It's actually pretty easy to handle.
Okay.
So we've done 2 mock disaster drills
Okay.
to simulate what it would have been like with COVID. And before I explain, before I go into it, there's one thing I wanted to point out too, because we were going back to workforce, and having these, what if we had these sites all across the nation where stuff could be produced? We actually did a quick estimate, and made the statements like, if we had started this back in 2018 and we had been able to get our program nationwide, if I had only had 8% of, let's just say, community college graduates across the U.S., for example, if I only had 8% of that entire body trained in additive, or we consider additive manufacturing literacy, that would have put a big enough workforce into existence that could have produced over 1 billion face shields in the first 60 days of COVID.
Wow.
Which,
1 billion.
Yeah,
That's a big number.
Deal. Yeah.
That's
that means that'd be roughly around 3 face shields per citizen.
Per citizen. Wow. So you could.
So,
wow, that's crazy.
only 8%. If I only had 8%
Yeah.
of each graduating class, of course, that's just not even counting the 4 years.
Right.
We would have had a workforce who could have used any type, any low-cost printer to produce face shields, and we could have actually had a nationwide manufacturing response
Yeah.
for folks to do from their homes, get to the post office, and distribute.
Right.
So that's kind of where this vision goes.
Right.
And kind of where we wanted to see with this. Now, back to what we're doing statewide. So each of our sites was set up with sidewinders. We had some enders and had some resin printers. So we knew what each site had equivalency of. And here's the catch with this setup, with this whole RAMI initiative. We were never allowed to train any of these people face-to-face because it was COVID.
Right.
So all of the training, and a lot of these folks were coming into additive at ground zero. They had never touched a printer, no idea. So we had to educate them and train them all at the same time. So we built instructional material. It's actually, a lot of it's on our YouTube channel, that guided them through every step, including the step of leveling. So to be perfectly honest, when we issued out the G code to all the sidewinders across the system, we had everyone in operation within 30 minutes of the start time, and I think the overall project, we had a failure rate of only 4%
Wow.
throughout the entire project. Now, what we did have different G codes, but they were all for the sidewinders, and they were all for the sidewinders enders. But what we did was we had different G codes for time. So we allowed each representative at each site to choose, do they want an 8-hour cycle, do they want a 16-hour cycle, or 24-hour cycle? What worked best for what they considered their operating time.
Right.
So that was the only differential between the G codes, because we had trained them pretty rigorously in how to keep their printer ready to go and keep it well leveled. So we actually had no problems with having to do multiple G codes for adjusting one sidewinder versus the other. They were all the same G code.
So I think that kind of puts that argument to rest, that that deploying across in such a distributed way would cause issues with environmental variability, and it will always to some extent. But the fact that you were able to pull it off, you had some level of dedicated facility. These are universities still, they're not manufacturing facilities, right, Eric?
Yeah, they're basically classrooms. I think one of them was in like a kind of a small closet. We actually live streamed some of the production. It actually happened on February 1st of this year at 9 a.m. Eastern time.
Yeah.
And we publicized that. Yeah, we had the entire system operational, various locations, various humidity levels, within reason, of course, and it was the same G code.
That's
but
pretty.
Everyone had the same training and expertise to make sure the printer was ready to go.
Right.
They were basically had it dialed in, had it leveled. They had no idea what the product was going to be. That was the other catch. They had no notion. They had never seen the file. They hadn't seen anything of it. All they knew is a G code is coming, and they need to have their printers ready, which is pretty realistic. In the event of this actually going down again, like COVID, you have warning to say you're going to be printing something tomorrow. Get ready. So that was fairly realistic for everyone.
And I think your approach there is really really well thought out, because a lot of the issues people do encounter with 3D printers, as long as they're running on good hardware, is slice settings. And so if you have a standard set of equipment that every location has, you can ensure that on your printer the settings are working correctly, and then just distribute that. And like in your case in particular, they almost need no knowledge of slicing at all. They just need to know how to make sure the printers are ready, which is what you did ultimately. And I think that's like I think that's a brilliant demonstration of just how we can use 3D printing for this idea of digital manufacturing and digital distribution. As long as you have a clone locally with an expert and he dials everything in terms of the settings, he can just digitally distribute this part to everyone else in the network. And as long as their machines are up to a similar standard with one another, they'll be able to replicate that part pretty much no problem. I mean, 96% success rate is actually far higher than I was expecting. I didn't know the number before you just said it, but that's like, that blows me away. That
it was higher than we expected to. It really was.
Yeah.
But yeah, they never saw an STL. They never
Right.
saw anything but a G code. So that, but we thought about that. That was our logic, is that they don't need, even though they were capable of doing a G code and slicing because of the training, it wasn't necessary, it wasn't relevant. Now, to push it a little bit further, back in May, I took a trip over to the Middle East, and we were working with some local folks to set up some 3D printing technology in places that didn't have it. And I claim that I have the world's first digital regifting, in the fact that after I got them set up, got our guys in place, and we set up like a link drive, before I left, they gave me a really cool hand-carved cross, just in appreciation. And so I brought it back, and so, of course, we got to show off what we can do. So I just turned around and scanned that sucker, took the STL, put thank you across the top of it, and sent him a G code. He never saw what the file was. So eventually, he loads it, he puts it up, and then out comes the gift.
That's awesome.
That's pretty cool.
That's so.
We got a picture of his dad holding it up. His dad gave it to us. So I got the first digital regifting. But that was the case.
Yeah.
Never had to do an STL, no slicing. I knew what the printer was. We trained him on how to keep it set up, and tutorials to provide, hardware replacements and how to get it dialed in. And we could just beam G codes back and forth.
That's the cool thing about G code and slicing. If you have a really skilled person who can slice stuff, there will be a little bit of variability between printers, but you can kind of slice things in a way that kind of gives some wiggle room for failure. Yeah. So you can make it so that the first layer won't be peeling because you know that you've got to print it in a certain way. And even if they didn't level the bed perfectly, that it'll still print out fine.
Yeah, you can just compensate with the first layer thickness is what you're thinking, right?
Yeah, well, I was just thinking that, like, if you have your printer set up so that you have a really generous, like, thick first layer, or I mean, even
a raft.
Reusing rafts is maybe what you would go for.
Like,
you can just pretty much compensate for, like, inabilities on the other end.
And where it's more mission critical, you outfit your centers with better hardware.
Well, yeah, actually, I don't know if you know, Eric, but there's like an X2 version of the Sidewinder that comes with auto leveling built in now, and a bunch of other kind of cool features. I was just looking at it. Of course, you're probably fully aware.
We've been watching it.
Yeah.
We've been waiting for that to come out as part of our next phase too. So we've been very excited about that.
Mm-hmm.
But yeah, it's all about here's the thing. Additive's all about the mentality. But I guess what we realized too is that you only need one person to have the mentality. In reality, in this scenario, you can literally just have one person at the top that really understands the slicing, and as long as the equipment is maintained to the specification of the entire group, that one person is all you need to produce hundreds and thousands of parts. I think we produced in the 72 hours of our first mock disaster drill, I think we produced, was it 1,600 maybe, face shields in that first 72 hours with a 4% failure rate.
That's really good.
Amazing.
It was great. The second mock disaster drill we did was in May after I got back, and it was actually on the resin-based stuff. But I think we produced like 6,200 nasal swabs, the Gen 1 nasal
Oh
swabs
yeah.
that were used for COVID. We produced those out of resin, 6,200 in 72 hours. And again, it might have been less than 4% failure rate on those.
Mm-hmm.
Same story. G
Same
code just
thing.
goes out, everybody starts.
Yeah. That's crazy. Hey, and not to one up you, but if you had a couple more Quinleys in there, when we were doing face shields, we were getting about 1,000 every 5 days for 9 printers.
Yeah.
Yeah. Make no mistake, I wish I had, because
Yeah, I know.
I was the one, coming in the middle of the night to reset those things.
Yeah, that's where we're going though.
Yeah.
Yeah.
That's exactly, and that's one of the reasons that part of our Raimi system, not all 10 sites got them, but our first 4 or 5 did get the Quincy systems that they're updating their enders with now, so that they'll be automated too. So, once we actually, because Raimi was begun before we even met, but once we actually found out the system and got it tested out, we put it into our Raimi system as well.
Yeah, it's awesome hearing the results and learning from the results and seeing like where we can improve Quinly to make it even more optimal for this use. And this is such a critical use of 3D printing and in general.
Yeah,
So
it's just
yeah, it's
cool to see.
awesome.
Like having people that haven't touched a printer before, being able to train them, teach them how to like level a bed, maintain the printer, load filament, and they don't even need to know what a G-code file is.
Yeah,
They just actually get
the
get
fact
parts
that
start printing.
he's proven that is outstanding, I think.
Yeah, actually, like Robert would probably be interested in this section of the
Yeah, we
live
need to
stream.
clip him this.
Yeah,
There's someone in that we're working with in Texas that would be very interested in these results that you got.
hmm
It was we kind of expected a little bit more of a failure rate, honestly.
I would have thought that too, but like I guess I mean Sidewinders are their reputation is good hardware as long as you maintain them. So
Well, the thing I like to say is that humans are the most unreliable
Yeah.
part of 3D printing.
that's true.
So when you take those away,
There's
then
no way we wanted them slicing that themselves, and there's just no need. They
Yeah.
just need to down. And I think the leveling routines, the guidance we provide on the leveling is probably the crucial thing.
Yeah.
Typically keeping your hot end good, changing out when you need to, all that's fairly straightforward. But the leveling is usually what gets you, and so we just compensated for it. Everything is ready to go.
Robert is here.
hello, Robert.
Scroll back 15 minutes, Robert. You'll find it interesting.
Yeah.
I think also what we'll probably see, and this is more on the software side, as artificial intelligence is used more and more toward additive, right? Here in this lab, we use a lot of generative design. I don't have any samples of it, I pull out on the screen. But it's those ladder structures like the donuts that we show. It's the new components that are designed better for additive by a computer, and it knows better. So even some of the issues we have with leveling and adhesion, we're going to get computers making better decisions,
Yes.
giving us better products that makes it even easier to G-code.
Yeah.
Now I have this product that's ultimately designed for a printer within a certain build area and a certain Z-axis weakness, and it's just G-code, send it to the printer. And, somebody keeps it dialed in, especially with the Quinly system, somebody keeps it full of filament, 74 parts, and they only spend 10 minutes on it, and it's just going to be that over and over.
Yeah, and that's something we've been working on too, adding machine learning into our Quinly system. It's in the development stages now, but that's kind of the next step. Like automation, we've got automation done. Now we need to make the automation smarter.
Yes,
Absolutely.
smarter.
You
Don't
need
say
that
it so
feedback
so
I think
it's
Smarter.
maybe ought to bust that one out too before we start talking about it. But that is
yeah.
that next phase of just machine learning to improve what we're already doing, and now that ball is rolling, it's just going to get better and better.
And I think that like we already are starting to see really, really good tools coming out on the front end in terms of like you mentioned, the part design and some setting stuff. And what we'd really like to do with our system is tie back the back end to the input, where the Quinly system can monitor and observe the parts for visual defects or for potential slicing issues, and then provide feedback to the front end, and maybe you're, I don't know, constantly under extruding a part because the material is behaving weird, and then provide feedback to initially the user um, to fix that.
Yeah.
But eventually,
Or automating the
yeah,
whole G-code correction issue. Like,
eventually putting it back into the slicer or back into the live printer management, so that it can self-correct within a certain tolerance, right?
yeah, well, just imagine a printer that can see the first layer go down, and if it notices little gaps between the lines, and it brings Z up a little bit.
Yeah,
Or if it, notices that it's under extruding a bit, it just bumps temperatures up by like
right.
5%.
Right.
So there's a lot of potential for improving the reliability of unattended printing.
I think
I like that. Unattended printing. That's another good one.
Yeah.
And I throw in the acceleration factor. I mean, look how far we've come since 2015 or 16.
Oh, yeah.
And with this much technology and the ability to iterate as fast as we are now, maybe 2 years. We saw generative first introduced, I think, in 2017, and by 2018, at the end of it, we were already having it in the classroom.
Right.
So that kind of thing is where, we're going to see everything improve, especially when it comes to AI. So I'm very excited to realize that it won't be long until that is a reality.
Yes, for sure.
Yeah, looking forward to it.
Yeah. I guess as we're coming up on the end, I did want to show off 2 of our Quinly setups that our Discord users have. I'll send you photos of these just after the stream, but here's one that's been put together by machine creators in our Discord. He's got an awesome, well, he's got auto leveling, obviously, and then he's got an awesome cooling setup. Do you recognize this setup?
Is this the Hero Me?
The
Could be the Hero Me.
shroud reminds me of the Hero Me, and why and how it's so modular.
It's got a nice color scheme too. Everything's in red.
And what I like that he did was he replaced our front panels with laser cut ones and actually engraved his logos on the front panels at the bottom there, which is cool. And then we have 3D by JB, who's got the DIY Quinly, and he printed it in a red theme, and he's also come up with his own tilt frame for it as well.
Yeah, I like the new looks that people are coming up with for Quinly.
I like it too. It's pretty awesome. Yeah, but I guess as we're recapping or ending our stream with Eric, I have to thank you so much for your time, and maybe just to recap for anyone who's joined us at the end and is considering going back and listening to it. We started off talking about Professor Eric Wooldridge's program at the Center for Additive Manufacturing Excellence in Kentucky, where he's set up 10 different sites, and he's been working on you've been demonstrating an emergency response program with distributed manufacturing entirely on 3D printing, and we went through some very, very interesting results with that. The fact that even with untrained people at these sites, you're able to achieve a 94% success rate.
Mm-hmm.
And the other thing that Eric's been working with us at 3DQ on is studies on how the Quinly system reduces part costs and reduces labor time and lead times in general. And he got some very impressive and very interesting results with that. I think we've also, the results themselves are being published separately soon.
Yeah, we'll be putting out a white paper eventually showing how like 3D printing at scale is actually quite viable compared to injection molding, even at like ridiculous high part counts, like 100,000. That doesn't seem possible at all, but with automated 3D printing, it actually makes sense.
Yeah. And of course, the discussion about how 3D printing has the opportunity to move our manufacturing world away from concentrated manufacturing clusters in overseas that are subject to environmental disruptions, political disruptions. Eric, who works with the US government, understands that these distended supply chains that cross borders and have to go through many, many different governments of regulation is actually a matter of national security concern as well.
Yeah.
And not to mention the economic and environmental benefits of switching over to a 3D printing system and manufacturing locally in a more decentralized way. Like the benefits there are just massive. Yeah, and at the very end, we talked a little bit about where Eric's results with our system and with his tests could take 3D printing into the future. And I think we're all very, very excited about how that's going to go.
Yeah, well, it's cool to see that 3D printing does seem to be a really good way to push things forward in terms of manufacturing, sustainability, and just overall like cost savings in general.
Yeah.
And it's cool that Eric's kind of like on the forefront of this, training new people and setting up distributed networks for 3D printing.
And actually putting them to the test.
And actually using them for really cool things, you know, supplementing supply chain issues during COVID or whatever future emergency events may end up happening.
Yeah, we'll let you have the last word here, Eric, if there's anything you want to add.
Well, it is always a pleasure to be able to talk about what we do. Now, if anyone is interested, you're welcome to check out some of our social media platforms, the Additive Guru. You can find me on LinkedIn pretty easily, Eric Wooldridge and 3D printing, or you can probably just actually Google Eric Wooldridge or Eric in Kentucky and 3D printing. You're going to find some stuff that we have. Our objective is to put this into the workforce and to push the needle, the mindset of additive manufacturing, that push that needle as far as we can, because additive in so many ways is the next step for innovation. You know, we're talking about products that are, you know, lighter and faster and stronger simply because this technology can make them. You know, our conversation today shows what we can do in the making across a broad scale and with very little investment. So for small businesses, this is an amazing opportunity, and that the ability to automate your printing on top of all these other benefits is even more profound on a cost basis. You know, the more you're out there selling your product, the more you're out there publicizing and marketing, that's what drives your sales up. We want you doing that versus worrying about manufacturing. Let the printers go. Figure out how to actually let them automate, and then you focus on getting what matters to your business. So many applications. One of the reasons we're so passionate about 3D printing, and one of the reasons we're so passionate about this particular system and just running that data, is to just get it in the hands of people that want to use it. Now, if you're interested in, you know, if you're in Kentucky or even the U.S. and you want to take some classes with us, you can reach out to us. We're pretty easy to find. We are working on some initiatives that will be nationwide coming up, and you can see some of our other things. But yeah, we love what we do, and it's always a pleasure to be with you all and to talk about some of the new stuff. I look forward to the next time when we get to talk about some of the other little projects that we're working on too. So I'm looking forward to that a lot.
Definitely. And if you're not in the US, please check out Eric's YouTube channel, The Additive Guru. It's a wealth of very, very good information. Even if you think you know things about 3D printing, I've looked at the videos, I've watched the videos, and there's a lot of new ways of thinking and also just really good refresher content. I would totally recommend watching that. So Eric, I have to thank you so much for your time, and thank everyone for watching. If you want to message or interact with us more, we've got our Discord channel. As Eric mentioned, you can find him on LinkedIn, message him directly or through his YouTube channel, The Additive Guru. And yeah, keep printing. It's going to be exciting to see where we can take 3D printing in the next couple of years. And yeah, thank you everyone for joining us this week. We'll be back next Friday with another stream.
Yep.
All right.
Thanks, Eric.
Thank you, Eric.
Have a good